Yeah. So I was originally asked to give a talk in sort of the other session that got merged with this one. So I've changed the focus of the talk a bit to specifically address this topic, which is to hose or not to hose. And what I'd like to do is specifically kind of review the evidence for the occurrence of fresh water at Site 609 and also the reoccupation of that site, Site U1308. And ask the question, what is the relationship between freshwater forcing and sea surface temperature and AMOC? And I should also acknowledge my former PhD student, Joe Nickel, because I'll be showing a lot of his data from his PhD today. So of course, Site 609 is a classic site that Wally and Gerard Bond used both to correlate the Heinrich events in this site to those of Heinrich on the Dresack Plateau, but also to correlate the variations in the percentage of Neoglobal quadrina Pachyderm O left with the Greenland ice core. And the primary evidence from Gerard's work for freshwater occurring during the Heinrich events was the planktic oxygen isotopic record from Neoglobal quadrina Pachyderma that you can see here in red relative to the percent detrital carbonate counts in blue. And what you can see is that for most of the Heinrich events that there's a significant planktic O18 anomaly. The magnitude of the anomaly sort of differs among Heinrich events. H4 seems to be the strongest, and if you look at H2, there's barely an anomaly there. And these anomalies in planktic O18 are quite important because they have been used to try to estimate what the freshwater flux was to the IRD belt during in this case, Heinrich Event 4. So this is from a paper published by Hodell in 2004, where they basically tried to reconstruct the freshwater forcing in the IRD belt between about 40 and 55 degrees north, based upon the planktic O18 anomaly. And they modeled this and came to the conclusion that during Heinrich Event 4 anyway, that the duration of the freshwater flux was about 250 years, and the magnitude was about 0.3 sphere drips or so. So the magnitude of the O18 anomaly is really important because it tells us something about the degree of freshwater forcing. Now, in 2008, we decided to try to measure the oxygen isotopic composition of the actual detrital carbonate grains within the Heinrich events. And what we kind of found to our surprise is that these detrital carbonate grains are very depleted in delta O18. So this represents basically each dot represents the measurement of a single detrital carbonate grain for all of the Heinrich events, H1 through H6, including H0 and 5A, at 3 sites proximal to the Labrador Sea going to 1308. And the only point to gather from this is that the mean delta O18 is about minus 5.5 per mil with a significant amount of scatter, but it's significantly depleted in delta O18. So then at 1308, which is the exact companion site of 609, we measured in the upper 5 meters of the core. These are the detrital carbonate delta O18 grains, again averaging about minus 5 for each of the Heinrich events. And then we just measured the delta O18 of the bulk carbonate, which is in red. And what you can see is that during the Heinrich events, the bulk carbonate, which is most of the carbonate, the delta O18 value of that approaches the delta O18 of the detrital carbonate, at least in H1, H2, H4, and H5. Doesn't quite reach as low values during H3 and H6. Now compare that with the oxygen isotopic record from N. pachyderma from the site. And so an average value for N. pachyderma during the glacial might be about 4 per mil or so. So one of the issues is that you have Pachyderm O, which is about 4 per mil. This is a single specimen that I cracked open with a dissecting needle. And you can see that that specimen is filled with fine-grained detrital carbonate that has a delta 18 of -5, and of course is also dead in radiocarbon. And so what this says is that if you're not meticulous about cracking each planktic forum open and cleaning all the detrital carbonate out, that the delta 18 anomaly that you get is exaggerated, and also any radiocarbon age that you get is too old. So we then kind of did 1308 like Gerard did at 609 and compared the two. So again, this is the delta 18 of Pachyderm. The blue circles are Gerard's record from 609, and the black record is the cleaned Pachyderma. And then we also replicated them. That's what the red dot says, it just represents a replicate analysis in each of the Heinrich events. And what you can see is that with kind of meticulous cleaning, it does reduce the size of the anomaly, for example, here in H4, but it doesn't completely eliminate it. But for most of the events, it does decrease the magnitude of the anomaly a bit, which would then also suggest that the amount of freshwater forcing might not be quite as great as implied from these data. Now, the other thing that we've been doing to recognize sort of Heinrich events is high-resolution XRF scanning. And this shows basically the low-resolution, 1 centimeter resolution XRF data, again for the upper 6 meters of 1308. And in blue is the calcium record, and in red is the strontium. And for the most part in this core, calcium and strontium are highly correlated, and they just reflect variations in the proportion of biogenic carbonate. And that's because biogenic carbonate, like foraminifer coccoliths, have a lot of strontium compared to inorganic carbonate, which, like detrital carbonate, which has a low partition coefficient. So you can see that what happens in the Heinrich events is that the calcium increases, but the strontium may increase a little or is much muted. And so actually when you take the ratio, it's a good proxy for the amount of detrital carbonate, and it matches the magnetic acceptability and density records. So this is an image then of Heinrich event 1 in the A hole of 1308. And you can see it here. It has a sharp base and is more bioturbated, more diffuse towards the top. And these are the calcium and strontium plots. And if you ratio them, what we found is that it looks like, at least in this hole, that Heinrich event 1 has 2 distinct calcium strontium peaks. So we wanted to see if that was real, because the XRF really only images or takes data from the upper millimeter or so of the sediment surface. So we sampled at a 0.5 centimeter resolution across this event, and Joe Nickel counted the IRD. In red is shown the percent detrital carbonate, and this brown is the percent total IRD, and indeed you can see that there are 2 peaks, and also 2 peaks in the bulk delta 18, and this is the calcium strontium. We also obtained 2 radiocarbon dates, again by meticulous cleaning the forum, so we made sure there's no detrital carbonate in it, at the base of these 2 events, and these are the radiocarbon dates in C14 years. Now, of course, to go to calendar years, you have to assume some reservoir age and then correct to the calibration curve. So it's difficult to say what the exact age of this is, because it depends upon what you take for a reservoir correction. So this shows the 2 dates for the lower event and the upper event, and then different assumptions for what the reservoir age might be, going from 0 to 2,000 years. And of course, 0 is unreasonable. It's at least 500 and probably older. So we'd say that the older one is probably somewhere between 15 and 17 and a half, and the upper one maybe 15 and a half and up to 13 or so. Now, one of the ways perhaps we can constrain the ages of these events is to look at the Hulu Cave record. So this is the Dello 18, a smooth record of the Dello 18 of Hulu Cave. And of course, this event, which is a weak monsoon event, which occurs just younger than 16 Ka, has been associated with Heinrich Event 1. And you can also notice that in this record, even in the unsmooth record, that there seems to be a smaller dip here as well. And so one possibility is that the two events of H1 actually fall at these two times. And the estimated age then, if that were true, from Hulu, at least for the base of the two events, would be about 16 and 15.3 kiloyears. And the implication for that is that the lower event would have a reservoir age of about 1,500 years, whereas the upper one would have a reservoir age of about 500 years. So it's within the realm of possibility. Now, the next thing I wanted to address is the relationship between the Heinrich events, the A and B event, and changes in sea surface temperature. And what Gerard, Bond, and Wally said early on is that the Heinrich events actually occurred in a already cold ocean. And you can see that from these data. So in green is the N. pachyderma. This is the percent sinestral N. pachyderma record. And then these are the two detrital carbonate peaks. And what you can clearly see, which Gerard and Wally pointed out many years ago, is that there's a very high abundance of sinestral pachyderma, right, prior to the occurrence of the Heinrich event. So that means that Heinrich event 1 occurred in an already cold ocean. And then actually within the Heinrich event, the percent declines. And then, of course, after H1A, we have a strong warming, not shown here, but associated with the bowling. Now, this is Gerards data from 609. This is percent detrital carbonate. And even with this lower resolution data, it suggests that there are two peaks to H1, A and B. And if you overlay his sinestral and pachy record, essentially it shows the same thing, that it was cold prior to the Heinrich event. So I think this is relevant to the relationship between Heinrich event 1 and Heinrich stadial 1, which is longer than the Heinrich event. So then what is the relationship with changes in deep water circulation? This is Jerry McManus's protactinium thorium record, which shows a decrease in the strength of amok as early as about 18 kiloyears, which stays low until the beginning of the bowling Alarod. But if this dating of the two Heinrich events are correct, then the Heinrich event 1, A and B fall in the younger part of the sequence, which then suggests that amok, so the surface ocean was already cold and amok was already reduced prior to the occurrence of Heinrich event 1. So then, just kind of to summarize, the volume of meltwater may be overestimated for Heinrich events if the foraminifera were not cleaned properly. And similarly, the radiocarbon dates of unclean foraminifera are likely to be too old. There's some evidence that Heinrich event 1 may have been a double event, and again, based on a wiggle match to Hulu, the best estimates for that would be about 15.8 and 15.1, and that cooling of surface water predated Heinrich event 1, so that the Heinrich event already occurred in a North Atlantic Ocean that was quite cool, and then warming occurred shortly after. This should be H1A, actually, the younger event. And then it also seems that the slowdown of amok predated Heinrich event 1, although amok may have slowed even further due to freshwater forcing during the actual Heinrich event. Thank you.